Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a reaction to the latest InfoQ software architecture and design trends report. This happens periodically, and I think we reacted until now to like 2 or 3 of these. And they are always interesting because they show trends and various ideas that come into the common consciousness of software development, and so it's interesting to review them and to see what architects are trying, what they are thinking about. So let's get into it. This was published on April 5, 2024. The authors are Thomas Batts, Laureate Application Architect at the Blackboard, Blanca Garcia Gil, Independent Consultant, former Principal Engineer, Aaron Stiller, Principal Software Architect, Daniel Bryant, DevRel and Technical Leader, InfoQ News Manager, QCon PC. I don't know what a PC is. Maybe you do. Principal Chair. I don't know. Rafal Gunkarts, Principal Architect and Engineer. I will post the link to this article so that you can read it for yourself, but you also have here a QR code that you can use to go straight to the article in case you feel like it. It's basically Architecture Trends 2024. Generally, if you search for it, you'll find it. So let's look at what it's doing. As usual, it goes into the adoption curve, and it looks at various techniques and where they are on the adoption curve. And it's interesting to see what are the differences and what are some of the things that are here. And let's start with the late majority, serverless reactive programming. Okay, so many people are using reactive programming. That's interesting. Now, I would expect this, but I haven't had a lot of contact with people doing reactive programming. But it's very useful, particularly for real-time data feeds. I imagine there are a lot of applications for financial systems, but not only. It can also be weather systems, stuff like that. HTTP2 and gRPC. Okay, event-driven architecture. CQRS, command query responsibility separation. In case you don't know this pattern, very useful pattern. It can apply at various levels. At physical level, it might mean that you separate a database replica for reading that eventually synchronizes with the database used for writing. And you can do this fairly easy on cloud systems. But it can also mean just separating in your code your commands from your queries and to data sources. And data sources can be databases, but can also be external web services and so on. And in general, I feel that separating commands from queries, it's a really good idea. You should probably do it even in a monolithic application that uses a single database. It's still a good separation. It simplifies the code. It makes everything nicer. Event sourcing, okay, interesting. I think we still have a lot to learn about event sourcing. In case you don't know what event sourcing is, it's fundamentally storing events instead of storing the current snapshot of the data. And occasionally apply the set of events on the data so that you get the latest snapshot that you can query. It's very useful for analysis, but it also simplifies things. And it's also a functional approach to architecture and to data storage. It's a very interesting technique, and I think more people could benefit from it, and actually we don't really know all the possible benefits we can get out of it. So yeah, it's gonna be interesting to see where it's applied. Eventual consistency, this goes hand in hand with the next one, microservices. And domain-driven design. Okay, so domain-driven design is lane majority. I wonder what they understand from domain-driven design, because domain-driven design is a huge umbrella for things. Yes, fundamentally, it's about figuring out the domain model and considering it as the most stable part of your architecture and then building everything around it, and then using certain design patterns for building things around it. But it's more than that, because you get a lot of different derivations. CQRS, for example, is one variant of architectural style derived from domain-driven design. So, and event sourcing is another. So actually, it can be a lot of different things. My guess is people are doing domain-driven design for microservices, and then they have to do eventual consistency. So this is how these get together, and they were all pulled in by microservices. Early majority, low code, no code. Okay, so apparently this has crossed the chasm, if I remember correctly. We'll see the changes in a moment. But the thing here, I'm still not fully on board with low code, no code. I think it can do a lot of things, but we also need to pay a lot of attention to things like testing and debugging and security. So I'm really curious what people are using in their own architecture from low code or no code, because you are basically moving security to third-party system, but maybe there are some systems that you can install inside your enterprise infrastructure. So, and that allow you to do low code, no code. I don't know exactly here, so it's gonna be interesting. Architecture decision records, we discussed about those number of times. Really good practice, highly recommended. More people should do it. I'm glad that they have crossed the chasm and they are in early majority, but they really should go to late majority. Modular monolith. Okay, so this is relatively new, and I really like it. It's good that we now have microservices in late majority, but we are starting to think again about modular monoliths. Cool. Actor model, really good model for messaging, even inside the monolith. So I'm not sure why it didn't catch more. I think it has a lot of benefits. I'm experimenting with this myself. I wanted to do a video that shows the messaging part of object-oriented programming, and I think you can show it through the actor model really nicely. And I did some experiments, but didn't yet get to the point where it's a video, you know. GraphQL. Okay, I'm not sure what to think about this. I imagine this comes with React or around those lines. Service mesh, yeah, good idea. Functional programming, early majority, okay. I wonder what it refers to, because there are functional programming constructs in all the major languages right now. But is this about using actual programming languages focused on functional programming, like Haskell, Scala, and I think there was one for JavaScript. Or is it about using functional programming in the widely used languages like C#, Java, C++, Python, and so on. Let's look at early adopters, platform architecture, socio-technical architecture. Now this is really interesting. Very interesting. Large language models, cool. Okay, I'm interested in how they are using those. Because, you know, there are all kinds of issues with large language models. Some of them are legal, which will probably be sorted out through a number of processes in the next year. Like processes, by processes I mean in the courts, in the judicial courts. But there's also problem of security. There's also the problem of that they are always creating things. So hallucinations, as they are called. But that's actually the way they are working. So it's interesting to see where these are used. Edge computing. Okay. I expected that, and I think this will go. I think if we get a battery that can work for mobile devices that is small enough and with higher capacities, we'll see more of edge computing. Right now, the bottleneck seems to be not in the computing itself, because we can pack quite a lot of processor power and computing power and all kinds of specialized processors there, but it's more in the battery life. Some things you just cannot do because they will drain the battery too quickly. Data-driven architecture, Dapper and WebAssembly. All right. We talked about WebAssembly. So WebAssembly is a very interesting technology because it started as a way to allow us to write applications on browsers that go beyond the limitations of JavaScript, and so that you can use other technologies, the most common one being Rust. But what is very interesting about WebAssemblies is that they are sandboxed by default. All the applications are sandboxed by default, which means they have increased security by default, which means that you can actually maybe make strong modules with strong boundaries using WebAssembly. And this is something that I know people were trying out. I don't know how far we have gone with the technology, but it's really something that I'm excited about. I can't wait to see more of this. Micro frontends, I wonder why it's only now in early adopter, because micro frontends were a design pattern for UIs from a very long time ago for microservices applications. And I wonder why they lagged behind. Maybe people were too busy doing microservices and figuring that out. And now we got to the point where we figured that out to a certain level, and now we think about UI and how to organize it better for microservices applications. Async API. Okay, I understand the terms, but I don't know what async API is, and open telemetry. I think I've read about this, but we'll have to see. Now, innovators, cell-based architecture, privacy engineering, green software, GraphQL Federation, HTTP3, and DApps. I know almost nothing about this, so let's see. Okay, so let's start with the key takeaways. Organizations are adopting cell-based architecture. They contain and isolate a set of related services. The benefits include reduced latency, increased reliability, and cost savings. All right. The thing is, in some of the first case studies for microservices. This is very similar to what they were using back then. They were using something like, yeah, they used the concept, actually a river metaphor. They had rivers and, how would you call them? Large rivers. I don't remember the English term. And basically what you would have is different levels of message queues. So imagine you'd have Kafka at a high level where all the messages would go, but then you'd have Kafka on lower levels where some messages will be posted that were relevant for the local set of microservices or for a group of microservices. So this is kind of what I see here, but I imagine that these microservices from cells are also calling each other directly. And in order to do this, reduce latency, increase reliability, and cost savings. Okay, it's interesting. We are basically going back to the good practices from when we started doing microservices, but that were lost through the folklore while developing microservices architectures. Innovators in privacy engineering are proactively designing systems with the security of users and their data as their primary consideration rather than simply responding to security regulations. Okay, that's a good thing. That's an example of what regulations can do, and that's good. I think this is a good idea. Just build the application, design systems with the security of users and their data as the primary consideration. Yeah. Data continues to be a major force in architectural decisions. Complex analytical frameworks and ML models are no longer considered secondary components as they shift towards core part of transactional systems. All right, I expect that. That's, of course, we'll need to analyze more data. In the past year, large language models have become a common feature in nearly every corner of the industry, but significant innovation opportunities remain to take LLMs beyond glorified chatbots. So only that. Okay. With the ideas from team topology spreading across the industry, architects are giving more thought to the socio-technical factors of who will build and maintain the components of a system. That's interesting. So once again, a patterns book, because team topologies is a patterns book. Only it's organizational patterns rather than software design patterns. Influences the industry a lot. So that's cool. All right, let's look at the updates. This year brought a comprehensive review of everything that was on last year's graph. Some of the broader theme items have been replaced with more specific tools, technologies, of patterns. For example, the past few years included several design for concepts that intended to showcase the utilities and quality attributes architects considered in the trade-off analysis. This means some items which have appeared for several years are no longer on the graph and in their place is a more specific aspect of the same concept. For example, private engineering, more precise than design for security. Similarly, green software has replaced design for sustainability. The innovative trend here is considering a system's carbon footprint from day one rather than being reactive when cloud cost and the corresponding energy usage gets too high. Cool. I predict this will happen. I was discussing with architects and in our courses and not only, and I always thought that there will come a time when we'll need to take the carbon footprint into account. And now the interesting thing is that there are different levels where you need to take the carbon footprint into account. The easiest one is on the cloud side and on the data wherever you store your data in your computing power. Maybe you have it in house, but in your data center. But there it's easier to measure because you can measure the energy consumption, and it also makes sense to reduce the energy consumption, which also reduces carbon footprint. You can also turn the energy consumption to greener sources like solar or whatever other sources. And so it's easy to manage on the side of operations. What will be also interesting is I'm wondering if at some point we'll start to pay attention to the carbon footprint of developing software. Because if you take something like C++, and actually that's an open question because I don't know the answer. I know there were a few reports back a few years ago, but I wasn't certain they were correct or precise enough. But the thing is, you can measure the carbon footprint of compilation, of debugging, of all these things. So I wonder if those things will make us change the way we build software, so that we reduce the carbon footprint, not only for operational considerations, but also for development considerations. Cell-based architecture is a new addition to the trends graph appearing in innovators. Overall availability and fault tolerance can be improved by giving extra attention to how and where services are deployed, restricting communication paths between services, and isolating faults within one cell. Yeah, of course. Socio-technical architecture is replacing architecture as a team sport as an early adopter trend. This trend also emphasizes the importance of Conway's law and designing complex systems that are built and maintained by many teams. Yeah, don't try to fight Conway's law. Another substitution for a specific trend of a general idea is the reintroduction of Dapr to the graph this year, replacing design for portability. I still don't know what Dapr is. I remember that I looked it up a few times, but I couldn't. Okay, let's try to search it. Dapr, distributed application runtime, a set of integrated APIs for communication, state, and workload that leverages industry best practices for security, resilience, and observability. Dapr applications run on Kubernetes or on any cloud or edge. Okay. Maybe. Large language models moved from innovator to early adopter this year. Also in the early adopter category is edge computing. This was previously being tracked on the cloud and DevOps trend report and is now a topic that architects are incorporating into innovative designs. The last change was moving low-code, no-code across the chasm to the early majority. As with many architecture and design trends, this does not necessarily indicate a majority of companies are actively designing and building no-code solutions. Rather, the level of innovation has plateaued and the patterns to follow are well established. Oh, okay. So it just means that we now have gotten pretty much as far as we can go with those technologies. Well, I mean, that kind of makes sense because I haven't seen this in a while. There used to be a lot of noise, but then the noise moved to LLMs. So, cell-based architecture. One notable design being discussed lately is cell-based architecture of a microservice architecture deployed with services using an everyone talks to everyone approach. Cell-based architecture imposes routing constraints where services prefer calling other services in the same cell, which can often be an availability zone. This can lead to significant cost savings while also increasing performance due to reduced latency. Right, so that makes sense because when you are calling across the boundaries of availability zones, you'll have higher latency, but I think you also have higher costs. It probably depends on your cloud provider, but I have this feeling that I've seen somewhere that you pay higher cost. Okay. Roblox, Slack, and DoorDash are just a few examples of companies that have implemented cell-based architecture and seen measurable improvements. We believe this is an innovator trend, and many companies will start to adopt that. They look to right-size their distributed system, control cost, and improve system resiliency. So honestly, that makes a lot of sense, and it's basically applying domain-driven design once again, finding out your bounded contexts, and microservices within a bounded context will tend to communicate much more, and that's a good place to start. It might also be that you have some communication between the different bounded contexts, and maybe those need to be somehow how would you say, prioritized in order to be more direct. Yeah, so it's more about the routing things. Privacy engineering. While security has always been an important aspect of well-architected software, we're seeing innovations under the heading of privacy engineering. The innovation here is a shift from a reactive mindset, such as responding to GDPR, CCPA, or other regulatory requirements, to a proactive mindset where the security of users and their data is a leading design consideration. One example of this is DoorDash, which relies on personal data such as addresses and actively obfuscates or removes this data after a delivery has been made. Yeah, and this makes a lot of sense, you know. But on the other hand, it reduces the ability of an organization to create data models like machine learning and stuff like that from data. So, you know, this is why these companies are breaching privacy, because it's valuable. And this is also why basically all LLMs were made from public information on the internet, which raises a lot of copyright concerns. They could not have done it otherwise. No, it's the gold mine. And the question is this, you know, and for many of these companies, the question is, the models that we can create, are those more valuable than the privacy of people? So it's interesting. It's interesting what's going on here. DoorDash. Okay, I'm curious to see where this will go. Green software innovator. Although there is a fair bit of talk about designing sustainable carbon-friendly software systems, there is not widespread evidence of industry-wide progress. Yeah. For that reason, we see green software as an innovator trend and not yet at the early adopter stage. There are fewer real-world examples of companies leading the way in designing software to be green from the start. Yeah. I think we still need to work on that. And I think many companies will not work on that until they will be pushed to work on that. Let's not forget that the big data centers are probably, the electricity is provided by the same company, because Amazon, Microsoft, and so on have invested in ways to produce electricity for their data centers, because it's very expensive. So this also makes a difference, because some of that energy is green, and they will just push that. And then many companies will just say, yeah, we're using AWS, which is green, because look, they are using power that comes from green sources, and so on. And the question is this enough for what we need in current societies? And that's the answer that these companies and every company producing software will need to answer at some point. Socio-technical architecture is a new trend this year and encompasses several related ideas. One aspect is the role of architects, which has previously referred to as architecture as a team sport or as architect as technical leader. This encapsulates the idea that anyone can make an architectural decisions and that architects have a responsibility to mentor and teach others. The other aspect of socio-technical architecture covers ideas like team topologies and Conway's law. More companies are starting to realize that the design of a system must consider all the people who build, support, and maintain the system, obviously. While any one concept may have moved to the early majority stage, the comprehensive idea of socio-technical architecture is currently at the early adopter stage. Yeah. Large language models are gaining very rapid adoption and many companies are looking for a way to incorporate them into their systems. However, the number of novel interpretations is far more limited once you get past chatbots and retrieval augmented generation. For the purpose of this report, we're trying to be narrow in our description of LLMs, not using the actual biologically meaningless terms AI, and I'm happy for that. While predicting the future is impossible, the next year will likely see notable innovation on LLMs, possibly spinning off new innovator trends. So it's going to be very interesting to see what's happening with LLMs, because I've started to see reports that they have plateaued, in the sense that okay, there are still some extensions that can be done, but the actual core LLM thing is, or training a large language model is becoming more and more difficult because for once, there isn't enough data, even though they basically took the whole internet, but apparently they get to the end of this and to as much as you can do from this. And secondly, there's more data generated by LLMs that then gets fed back into LLMs, which actually reduces the training speed. So they don't learn more with more data because the data is generated based on the same patterns that LLMs used. So that's kind of interesting to see what will happen. On the other hand, there are some things that they can do. One thing they could do, for example, is delegate specific questions to specialized subsystems. So for example, if you are asking a question about logic, let's say, there's one answer that an LLM could give, but it can also delegate this question to another system that is trained specifically for answering logical questions, or maybe to something that's actually built to solve logical questions. So this is what will probably happen, I imagine. And I have to say, I don't expect AGI, artificial general intelligence, anytime soon. I think I've seen many reports, including Elon Musk, who said that, by next year, AI will be smarter than humanity and blah, blah, blah. But I don't trust these predictions. I think it will take much, much longer. And I base my information and my theory, basically, because we'll see what happens. I don't know what will happen. I'm basing it on Grady Butch, who has been working with AI for a very long time, and he keeps saying, AGI is nowhere near. There's much more to do. So yeah, it's an interesting trend. I have been playing around with LLMs, but we'll see. And I'm curious how much they will take part in software development. That's another question. Because actually they are kind of two big ways in which you can use LLMs. One of them is in order to automate development and or to assist development, and that's things like GitHub Copilot. And the other one is to train LLMs on your data and have kind of chatbots or maybe other things that you can ask. And then there are companies that are building more specific products for various things based on LLMs. And so you could take a third-party service to do something specific. But the problem is there's always this challenge of accuracy. LLMs are not accurate. So that's a big problem. Right, platform architecture. Several companies offer products to build platforms or help with platform engineering, which is generally a sign that something has crossed the chasm and has growing adoption. However, there is serious innovation at the intersection between how platform engineering is influencing architecture and the design of systems, and how architectural concepts are influencing platform engineering. This can be a symbiotic relationship where architecture is influenced by what is available on the platform and the platform evolves to suit new architects. Platform engineering is important to architects because the platform you build determines the architecture you choose. Okay. I'll have to take a deeper look at this and see what's it all about. Edge computing. Okay, so edge computing is basically designing system for the edge. So either running things as close to the user as possible or running things directly on the mobile devices of the users. That makes sense. Data-driven architecture. The category of data-driven architecture represents the shift of complex analytical platforms from being add-on adjacent components into core parts of transactional systems. For example, machine learning models are now used for near real-time analysis of data and events, which then drives other behavior in the system. This means those analytical elements are first-class elements of a system, and architects need to design them to have resiliency, performance, and observability, just as with any other major component. A related trend is MLOps, which is the intersection of data-driven architecture and platform engineering. Okay, interesting. All right, and this was the whole article because they just presented, the early adopters. So if we go back, they presented the changes basically. So apparently not much has changed in the early and late majority, but there were some early adopters and obviously innovators. I still don't know what DApps are. What are DApps? DApps. Oh, decentralized applications. Okay. Ethereum stuff. So blockchain-based applications. Yeah, I'm not that. Are they innovators? They've been around for a while and they don't seem to get very far, but okay. HTTP3 is an interesting one. That's actually the whole article. All right. So, what are some conclusions from here? I think I already said some of my recommendations. CQRS is a good idea. Event sourcing needs more people to look into it and figure out what we can do with it. Domain-driven design, I feel it's too big a category here. It should be probably something more specific. CQRS, something that you should do. Cell-based architecture, really good idea. I think that's something we should do. Green software, my feeling and my prediction is that we won't escape green software. It's just the question is how far it will go. It will only stay at the level of operations, so we'll also start discussing about the development aspects, like what is the carbon costs of compiling programs versus running virtual machines, and then do we need to optimize compilers, or there's all kinds of questions that we can ask here. And maybe it's not such a big problem. I don't know the numbers. Maybe the bigger problem is to reduce the energy consumptions of computers through various software optimizations instead of optimizing compilers. I don't know. That's a question that I keep asking, trying to figure out if it's interesting or not. WebAssembly, as I said, very, very interesting. I think this might be the next platform that we can build upon. Particularly if we need increased security, this might be the way to do that. Now, the problem is that WebAssembly is still pretty difficult to use based on what I've seen. So we probably need additional tools, additional libraries, additional, glue, code, IDEs maybe, I don't know, that help us write code or help more people write code in WebAssembly. Right now, the best information I have, which could be inaccurate because I haven't looked at this in a few months, but the last time I did look at it was that it was easy to do things with Rust, but then not everybody is doing Rust. So we probably need some more glue between the modern and the most used programming languages like Java, C#, C++, that facilitate the usage of WebAssembly. Also, it might be a big shift from what we are doing now. Like if you are doing Java microservices with Spring MVC or whatever, there's a framework for microservices from Spring, which I don't remember. But if you do that, switching to WebAssembly will be a very different way of doing that. So we'll have to see. But maybe WebAssemblies will fit with modular monoliths. And that will be an interesting trend to watch. And we still don't know how much functional programming is actually used and what it means to be here in early majority. Like, is Haskell used more? I don't know. Or Clojure? Who knows? All right. So that's it from me today. What do you think about these trends? Do you experience these at your work? Do you want to learn any of these things? Do you want to learn more about them? If you have any comments, if you have any suggestions, if you have any questions, please leave them as comments to these videos. We love comments. We answer all the comments, and we try to occasionally do videos when we have more interesting comments and actually answer some of those in a video form as well. So yeah, please leave us comments. We love to be in touch with you and know what you are thinking. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next week.